Ну что, друзья, давайте начинать.
So, okay, friends, let's start. In my life, I have never done anything as interesting as the replication between different databases. Good afternoon, dear colleagues, at the last presentation in the session. So I would like to greet those who survived to see that afternoon, and we're going to talk on how did we made MSSQL, PostgreSQL to become friends. We have written our own replication, and we switch one of the largest information systems to PostgreSQL. My name is Taras Chikin, and I work at one of the Perm database companies. Our unified digital platform in the healthcare that was launched after the two companies were merged has been working for more than 17 years, and it went a long way, starting with the client-server application in Delphi in a number of clinics in Perm to the large cloud system that works in different regions of the Russian Federation and even in certain regions of Kazakhstan. And today, this system has 34 regions of Russia and a few districts of Kazakhstan, more than 1,500 medical institutions. We have 35 million people registered in our system, various mobile applications for the doctors, for the patients, and all this together allows us to implement the national project of the healthcare. In our home region and Perm region, with a population of about 2,600,000 people, the system has about 40,000 users. I'm talking about the medical professionals. About 15,000 of them work in real time online, and 100% of patients have the electronic patient records. And they all get appointments at the doctors via mobile application. And about 17 million electronic documents are being registered monthly and more than 200 million yearly. And the database size is more than 5 TBs. Our neighbors, the Republic of Bashkortostan, where the population is about 4 million, and the system has about 86,000 users. 18,000 of them are online. So we're talking about medical professionals here, and 100% of the population has had the patient card registered electronically. And in Bashkortostan, there are more than 200,000 million appointments at the doctor and more than 900,000 of e-documents, and their database is 7.7 TB. Our front end is written in PHP 7, XJS, and various services are Java 8, MyBatis, XF are used for services. And we also use Apache ActiveMQ. We should say here that in our work, we don't use the framework that generate SQL queries because the system is under heavy load. So it needs optimization, and we are working with the pure SQL code. Is much easier than something that framework generates. So another peculiar thing about working here is there is a simple rule for a programmer. We read from the presentations and we do everything using stored procedures. And we have a lot of auto-generated objects that were created using special generators. Of course, sometimes you would like to do without any logic in your database, but still we have some. And up until this time, our architecture looked like a huge monolith database and a number of additional databases for reports, for registers, for the archives, and so on and so forth. All these databases were interconnected by the replication, and throughout all these 17 years, we have been using MSSQL starting since MSSQL 2000 version, but starting from 2013, after certain events, the Microsoft policy has changed a lot, and the licensing cost increased suddenly, and import substitution, this phrase, we started hearing that much more frequently. and as many other representatives who work with our state agencies, state departments, we started looking elsewhere to replace MSSQL in our work. Of course, for healthcare system in large area, large region, the amount of users and the workload in the system are going to be substantial, and the choice was also complicated because we are working with sensitive information which must be protected. So the solution must meet all the requirements and all the laws and rules of the country. And having studied the situation at the market, it has become obvious that from the open source solutions, we only have PostgreSQL. And after we have made up our minds regarding the platform, we started looking at the scale of the disaster. So that's some stat for the fields and BD. That's not as bad. So the number of the type that we use in our system is not that big, and everything is pretty convertible. But some exceptions are fields like version, the number of in MSSQL, and Postgres doesn't have this function, and a number of cases we just didn't do that at all, or we converted somehow, but that wasn't the most important thing. But usually it is easily convertible type by type. If we look on the BD object, that doesn't look as good. In our system, we have about 5,000 tables and about 4,000 images, 14,000 stored procedures, so it is quite large. And we also would like to draw your attention that there is a lot of scale and table functions, about 6,000. And if we look at the stored procedures, everything is becoming even more serious. A lot of stored procedures that are not auto-generated, that have their own logic inside of them. And here we need to start understand that all these functions, all the stored procedures, including the non-auto-generated presentations, these are candidates to be transferred manually. And of course, we need to compare the statistics. We need to understand what we're looking at when we need to transfer these application codes. By our estimates, about 600 PHP models, each of which has from 0 to a huge number of various queries. And by our estimates, in total, there are a few thousand of queries. And there are a number of Java servers, each of which has a certain number of SQL queries. And what is going on with the Java services? No one even counted what's going on there. And after having analyzed the scale of this migration, we were horrified. If the migration of the structure itself, the creation of tables, auto-generated objects, weren't as difficult, weren't as complex, I think we should think our strict regulations for the development that defines what types should be used, approaches should be used, the query principles, and so on and so forth. And in the end, what we had, that the number of weird situations, we didn't have a lot of those, and a lot of objects were migratable. And the table of functions, in majority of cases, we're talking about some kind of reports, the stored procedures, a lot of applied code, the platform services. This seemed like a Herculean task to do. And for quite a lot of time, we used monolith structure, and we have studied well both advantages and disadvantages of this approach. That's why we wanted to resolve all these issues during the migration and to work out all these various issues. And after having evaluated what we need to do, we thought that in best case scenario, we are going to spend 1 year to migrate all this data. And it all was complicated by the fact that if suddenly something goes wrong, then right away will be the talk of the television, in the newspapers, and no one is going to say anything good about us. So on one hand, we had the problem with the licensing cost of MSSQL, licensing policy of Microsoft that was restricting the use of certain features. with reasonable prices. Of course, the import substitution, that was the requirement from now in the state sector. Yes, and the hope was to make things better, and we wanted to try something new. But on the other hand, what stopped us was the large amount of SQL code for migration, thing that we stored views and services. So, and then it was maintained and developed continuously in a lot of various services. Of course, we have accumulated working with our monolith number of issues, large number of issues, and we knew that we still need the system running. We couldn't stop all the medical institutions. We can't stop them just for a number of days. So that's it. We can't just switch to Postgres like that. But still, we needed to do something. So let's start eating this elephant piece by piece. So we started with the table of the differences in the syntax, and we had quite a large tables and a lot of presentations. You've heard today that Oracle and Postgres have a lot of similarities. I'm not an expert in Oracle, so I believe the presenters, but we had quite a list of all the differences, the syntax difference, the difference in registered, in the functions, and so on and so forth. A lot of things, sorting, and a lot of stuff. And as you can see, we have evaluated, could something be replaced automatically? Only one or two things could have been replaced automatically, and all the rest took manual labor, actually. So right away, we're thinking about various solutions, what could have been done. Yes, maybe we chose the path that a lot of you also had chosen. We went to a lot of organizations that specialized in migration, but unfortunately the cost, the budget that we were given, it was too high. We tried to convert it using regular expressions, so something we managed to convert, but it didn't really work that well, so we dropped it. So we wanted to use the Antler to write our own converter, but after having read the documentation, we also dropped this idea. There was a presentation at this conference. They were representing Antler tool. I don't know how much effort they spent to create this, but we considered this also. We thought, how much time will we spend? And then we need some time to fine-tune it, so we dropped it. But Antler is a viable option, so it could be considered, actually. For certain queries, we use certain online converters. There is a SQL line online. It converts some stuff. Sometimes it does a good job of it. But in most cases, we had to do all the work by ourselves with our hands manually. And another important detail that you have to face is the data migration, data transfers. So we looked at the tools, free of charge tools and paid tools. Well, it didn't work that well. We looked at SQLine's data, SQL Workbench, and of course, there are some ideas to use FTW or copy, some other options probably. What we got in the end, we came to this conclusion: SQLine's data, by speed, it's one of the best working, one of the fastest tools, but unfortunately, it has problems with Cyrillic characters. It just doesn't recognize, doesn't understand Cyrillic, and it can also fail uncontrollably, so you can use it, but only when you're just working with some pure figures, pure numbers. SQL Workbench, the Java tool, proved to be the most stable, the most reliable one, the most configurable, and we are also using it now. And to speed things up, you can start a number of processes for different schemes, for different tables, to make them run at the same time. But if you need to speed things even more up, then you could use FDW and copy. But you need to understand one peculiar thing that has been talked about today is the support of actuality of relevance of data in the database. So, okay, we transferred everything, but we didn't have time to move to the new database. So it's a 7TB database. We can convert it without any interruption. And then we have a question, how can we update the data again? What do we do about it? But we will come back to return to that later. But the next necessary step is to transfer the database structure. We took a look at different tools, free of charge and paid tools, and like Liquibase, which is free of charge, finishing with the $150 tool. So we tried all of these with our volumes, with our scope, and that's what we got. These are the conclusions. Nothing worked out of the box in our case with our volume of data. Either it took too much time to work, like 12 hours, it used for 5,000 tables, then it crashed, so didn't work well. Some things, some structured transfers with errors, so didn't really work that well. So eventually we, after having analyzed everything, after having made conclusions, what needs to be done, so we chose Liquibase with certain improvements. Framework of Liquibase is an interesting thing. It is used to transfer the structure of the databases. It has one interesting peculiarity that really helped us a lot. All its files, it saves in XML. In newer versions, you can work with JSON, with YAML. I think they added something else. And it opens a whole array of opportunities and possibilities to work with this tool. I think we have chosen the simplest, maybe even the dumbest way. We just took and we wrote a tool. After you unload the structure in an XML file, it just works with the XML file. At the same time, we also finished up a number of things to support like the register dependent objects and stuff like that. In MSSQL, there is no dependent object, so you need to change the register in the lowercase characters to work with Postgres. And after doing all these things, we had a really convenient tool, really flexible tool. We can do a lot of stuff. We can remove quotation marks. We can replace types if we need, like charts in our chart, and we can change it back if we need to, and other stuff. We need to make some simple replacement of SQL functions just to transfer the representations. It's an important thing because MSSQL, you date, if we need it, we can change it to now. Some other things are possible. We can remove some hints, and of course, all this allowed us to add some additional steps in the change file. For example, after the object is created, we can start the script that we might need, and of course, the filtration capabilities of Liquibase by names, by object, and so on and so forth. It gives you a lot of options. So, and then we had a tool that we used to transfer the whole structure by blocks, by modules, and so on and so forth. And the most interesting thing that it showed quite a good speed at that. At the test workstation, it wasn't the server, it was just a workstation, not the fastest one. So the unloading the whole structure in that 5,000 tables, it took about 1 hour. The creation of the structure, it took 4 more hours. Well, fast enough. If you start at server, then it will happen even faster. And such a serious question, what can be transferred by structure? Well, of course, stored procedures. All of them. At all, there is no way to transfer them. Why? Because the differences in the syntax, the differences in the blocks, functions, makes automatic conversion impossible, and we didn't manage to find a converter that would have allowed to do that. Even a paid one, a commercial one, we considered many options, and even among commercial converters, we didn't find one that would help us to convert stored procedures from MSSQL to Postgres. Functions, these 6,000 functions, all the state reports, statistics, and all kind of reports that we had in our system. The same thing with these functions. Something is transferable. Yes, there are things that are possible to transfer that have compatible syntax and so on and so forth, but a lot of data, about 90%, must have been done manually. And part of the representations also are transferable, create view, and Postgres and MSSQL, they are alike, and there are a lot of platform-dependent code. We had author cross apply, all kind of functions, some specific things in the syntax, and again, we had to do that manually as well. And in our case, to wake up in the world where everything is in PostgreSQL is just a sci-fi. In our case, this situation was basically impossible. We can't stop our system for a long time just to convert or to migrate. We can't stop the current development because everything is being changed at all the times. There are always some modules that are not tested enough. There are some services that are just forgotten somehow. You always should have a chance to roll back if something went wrong. Actually, our task is to, change a car on a train that is moving fast, and solution for us was movement on several directions, progress in several directions. On one hand is the changing to microservice architecture, and we should divide here our huge monolith into several parts. We're creating API for their integration, and then gradually we switch to the new platform, to Postgres. So to say that's the right way, maybe it takes a lot of time, but we think it's the right thing to do, and our internal team did that, who knew the subject matter very well. And the second path is when we just take something and rewrite whatever we have. From one platform to another, we test it, and then we just try to make it work for starters.
But at this kind of approach, we need a tool that will allow us to connect PostgreSQL and Microsoft SQL and to ensure data transfer. We need to find a kind of integration, and without intervening into services, we can step by step migrate them to PostgreSQL. We needed a rollback feature and a hot database with actual data. If, for example, we will want to test something to migrate, and for this kind of task, we have written our own replication system. Long time ago, when our system was running on MSSQL, we had our replication. There were a few databases like main base, reporting base, data representation base, archiving. Everything was interconnected by replication. But back in the days, all MSSQL replication were not good enough for us. It's either they couldn't support our volumes, or they required a lot of efforts to support them, to maintain them. It wasn't okay for us when the database structure was changing, and everything required a lot of manual operations. It wasn't acceptable for us. We decided to use Symmetric.js. Symmetric.js is an open source cross-platform replication system. We were using it for a couple of years, given that the amount of data was growing too. The advantages are, it really works. Seriously, I mean it, it really works. It is replicating your data. It is smart enough if you update it. If there are some external keys errors, it knows how to get data. There are some flexible options and parameters. Data collection is executed by using triggers. It means that all changes, all updates get into the replication. There are other advantages too, like remote control, HTTPS support, groups tables, and other features. We used it for a couple of years. The volume was around 10,000 records per day, 10 million for Permian region, and we faced some problems. So routing process took too much time. It's when the system is builds the order of records. If there are some wallbacks, if there are some missed segments, and everything works too slow if your database is very big. Second is that it uses triggers to collect data, because it just put extra load on the database. If we change the write operation for a couple of times, all these updates go into a special table, and all these records are being accumulated in one big table. So obviously the lag was very high, around a few hours, which wasn't acceptable for us. So we could live with this by tuning something, by upgrading our hardware, but in latest versions there were critical drawbacks, such as incorrect records order. If we update them sequentially inside one transaction, symmetric couldn't do it, and the records were mixed up. For us, it was like something completely unacceptable. We thought that we needed something else. We took a look at other options. We understood that symmetric wasn't too bad. And so the task was to feed data from MSSQL to PostgreSQL by using additional filtering, conversioning, and so on. And we wanted to get a product with all symmetric advantages without its drawbacks. And we have made our alternative replication. Main principles are: for MSSQL, we are using raw version to collect data. We use it when updates or inserting records. The download gets from the maximum version of the latest package to the current version. We can collect data by analyzing audit fields. Also, we have written a raw version emulation by using transactions IDs, and in the next version we will work with WAL. The exchange format is JSON. One JSON message match each record in the table. On this server we keep only replication log. Then it goes to broker once the upload is over, and we are using Apache ActiveMQ as a broker. And also we tune the broker itself, and we can use different types of subscription. What can we achieve with this feature? So let's talk about its capabilities. It is cross-platform. It is written on Java. It can work on Linux or on Windows. It supports MSSQL and PostgreSQL. Everything, all settings are stored in a YAML file. It has different statistics, multi-threadness. Data can be fed by a standalone query or completely. There are some filtering options. If there are several entries that go one by one, they go to replication, and also you can use different models of subscription, and also it can be integrated with other services of our big software bundle. So it's like we're working with messages. We work with messages through queuing, and we can do this stuff. Also, we have mandatory list replication, and another interesting feature is we can process data through JavaScript. With JavaScript, you can process our errors. We can use standard broker policies. We can send a message several times, or if required, if the database crashed, the database is down, we can stop replication and send an error. The second thing is we can process data with JavaScript, and we are not limited with any ideas. We get this JSON message and we can modify it the way we need. We get some data from other sources, we combine them, we do something else, so scenarios can be very different. So, and here are the tasks that we are dealing with by implementing this thing. So the data transfer between MSQL and MSQL, data transfer between MSQL and PostgreSQL. So we can achieve this by applying this stuff. It works. We can exchange data between different structures. So we can get data by sending a query, we can apply filtering. It's very flexible to work with different structure objects because our software bundle is very complicated, and now we can send data between different components. The structure can be different both in MSQL and PostgreSQL, and by applying this solution we can finally do it. Async recalculating of different indicators. This is very helpful for reporting. We calculate something beforehand and so on. So we have some async data processing. It's like when one service allows us to put data into a queue, or otherwise we put data into a queue from replication and they go to a different service. This service makes an action. For example, it sends data to a federal segment or something else. So this stuff works fine. There is some loading, notification services, and some other stuff. Some statistics. For PIM, the replication is around more than 1,000 objects. So we have around 4.5 million messages per hour, and the speed is 1.2 thousand messages per second. And we cut down the processing time to several minutes. And this is how the general schema looks like for our medical information system. In the core, you can see this smart data transfer and data transformation. Our replication. With this replication, we can glue all these services, we can exchange data, we can get different indicators, we can interact with the reporting system, and so on and so on. And then this data can go to other systems and they interact with something. And on this slide you can see different parts of our smart system, like schedules, microservices, and so on and so on. And going back to our task, migration to Postgres, it is to be noted that there are some specialties that we have come across during this process. We were basically ready for a lot of things, but some of them have become unexpected. I'm not talking about things that I have mentioned in different syntax. There are some funny and unexpected things, such as sorting with nulls. In MSQL and PostgreSQL, it's absolutely different where null will be placed. So, special things that we have found. First, admin utilities. PGAdmin is very heavy, it's very odd, and we didn't like it. Here we use debiller, and we really like it. Also, I mentioned that functions are not being compiled, so you can make an error very easily. PG-check allows us to avoid it. Of course, there is no embedded task scheduler. Yep, Postgres Professional. We are using vanilla Postgres, so no external scheduler, but you can install an external one instead. Interesting peculiarities. A number of fields in the table. In vanilla version, it's around 100 fields. This is the limitation. We had tables with 200 fields. All we had to do is just to recompile the core and everything was okay. And I think that the main problem, the main specifics that we have come across and is optimizer. Well, maybe we are spoiled by a very good optimizer provided by MSSQL. And once we migrated to Postgres, some features of this DBMS have become a real pain in the head, like indexes and other stuff. So we want optimizer to be smarter, and we are trying to make friends with it. But there were some pleasant, unexpected things. Tables inheritance in PostgreSQL allowed us to reduce query size and to make our table structure more compact and readable. JSON support is worth mentioning too. In the last version we have it, but in PostgreSQL we really like JSON support and we're trying to use JSON as much as possible. There are some structures that better work with JSON. And one of the best things about PostgreSQL is that concurrent queries started to run faster. MSSQL blocks a lot. And a lot of time and efforts you spend on dealing with locks. It's a very big problem to avoid a lot of locks. And we have some system modules that really depend on locks, and they couldn't work concurrently. And here we run and it works just fine. In versioning structure, everything works fine in Postgres, and it was a very pleasant surprise. We really liked it. And a few words about our current stage of migration. Now we're using version 11. We are planning to switch to version 12. In production, we have a few modules that were rewritten for Postgres from scratch, like ambulance, like information system, schedule, and something else. All these modules are integrated with our main system that is still running on MSSQL. We use replication and API. Next, we are going to use this MSSQL part, and this solution works for our big regions like Perm region, Bashkortostan, where we have a lot of modules, and it is very difficult to switch to PostgreSQL in one step. And now we started to launch a module on stationary model, and then we will just divide everything into small services. And in conclusions, some conclusions about what we've done. The main conclusion that we've made is that it is possible to switch from MSSQL to PostgreSQL, but this will take some time. Sometimes it will take too much time. PostgreSQL doesn't have problems of MSSQL, but it has some specifics that you need to take into account. You need to design very accurate regulations on database regulations. like queries and so on and so forth. We've got these regulations, these guidelines, and it allowed us to cut down the number of unexpected things. The conversion itself of the database structure doesn't require a lot of time, doesn't take a lot of time compared to other tasks. And the biggest effort will be required to rewrite SQL queries in views, in stored procedures, and in applied code. And of course, after this rewriting of code, you will have to continuously optimize your system. So, at the end, I want to say that we will have more data on our medical information system running on Postgres, and I will tell about it next year at the next PGConf, and we will send this information to open source repositories. So happiness is here. Thank you very much. So I want to ask a very first question. So at the very beginning, I saw 5.3 terabytes volume. What about Postgres? Can't tell you exactly, but the structure is the same. Half of database is indexes. Given that the structure didn't change a lot, we have a test stand, but the order is the same. Maybe not 5 terabytes, maybe less, but the order is the same. Okay, thank you. Any more questions? Thank you very much for your talk. I'm sorry, but I didn't get it quite well. You've got MSSQL, you've got Postgres, you've got replication. In what database you make your updates, or it's a two-sided replication, or this microservice allows you to do it flexibly. So what is the data flow? Okay, thank you for your question. We have different situations. We have two-side bilateral replication. Something goes through microservices. The data flow is different. Everything depends on a particular situation. It can be different for different areas of application. So that's it. I've got two questions, very short. Are you using change data capture for MSSQL, and did you consider AWS replication, AWS schema conversion tool in particular? I will start with question number 2. AWS and clouds. We're not authorized to use these kind of systems because we've got federal law 152 in our Ministry of Healthcare just are not happy with clouds. That's why we're using hardware, local on-premises, on-prem infrastructure. That's why we cannot use AWS or something like this. Question number 1, no. We've got a system like this. Thank you. Any more questions?
Two quick questions. Have you faced any constraints on the transaction ID 32 bits? Did you face any problems regarding that? And the second question, could you give a more specific example what exactly you weren't happy with regarding the scheduler? So where Postgres scheduler failed to handle the thing that you had in the MSSQL database. Thank you. As for transaction ID, to tell the truth, when I was reading the documentation, I did that just not that long ago. It says that they have 64 bits transaction ID. Why do we have 32? They didn't make it for vanilla version, and the pro version that is not vanilla yet. Yeah, then no. It's in the air, but it's not implemented yet. But we are just testing it, so we haven't started. The last question, please. So whoever is can ask the question, we'll see it on the top of the final session. We can thank you for your presentation. I've got two quick questions as well. First of all, a small question, why and Vakchar, not CTX, because the problem there with the KSL city that you had. So in Vakchar and MSSQL, the Unicode text, and for the Postgres, everything is Unicode. And well, if it's in Unicode, then yeah, the question is resolved. And you talked about a lot of documents and the documents itself. Do you have it in database or somewhere else? I talked about the records in the database because the medical document in this case, that's the set of the fields in the database. And if we were talking about some actual document, for example, the one that we sent to the federal services using various other tools, then they are stored externally, so they have their own logic. So they are not in the database. Yes, they're not. Thank you. Thank you very much. That will be it. Thank you.